how exactly are these safety systems very different from your typical control systems? Hello everyone and welcome to a brand new episode of thoughtXchange. Today we are here with Mr. Asad Rahman, who has been a lead engineer with INTECH for quite a while.
Once you have identified your hazards, you might want to put some layers protections around it to make sure that that hazard cannot reach the worst outcome. One of the things that we do during the design phase and testing phase and validation phase is that we try to simulate the plant environment. The safety requirement specification acts as a backbone to or a design standard to this particular project that you're doing, right? So every project has a safety requirement specification. We have this process. So we have this PCS or scale up or whatever as a main process here. So which safety system would you advise us to go with? And that's where we take in all the knowledge that we have.
Hello everyone and welcome to a brand new episode of thoughtXchange. This episode is going to be focusing on safety control systems. Our last episode was on pipeline leak detection systems. If you haven't seen that one, be sure to check that out. So today we are here with Mr. Asad Rahman, who has been a lead engineer with INTECH for quite a while. So Asad, why don't you introduce yourself?
Okay, I joined INTECH back in 2014. Before that, for a year, I was working in LV switchgear industry for 1 year. And since 2014, I've been doing a couple of brownfield projects, greenfield, onshore as well as offshore.
So how about we start with an introduction to safety systems? What are safety systems?
Okay, I'll try to make it simple. Safety system is a set of software and hardware as well as the field instruments along with the loop configuration. All these combine together to achieve one safety action or multiple safety actions. The key criteria are response time as well as the availability. So if there is an unsafe condition on the plant, this system can bring the plant to the safe condition.
Okay. And what are some applications where these safety actions need to be taken?
Typical applications would be pipeline protection system, fire and gas system, some refineries, fire and gas system, as well as offshore facilities. And then there'd be some predictive maintenance systems, right? And then normal safety shutdown systems.
So how exactly are these safety systems very different from your typical control systems? Can't you do the control part to also perform the safety functions?
Okay, Ahmed, you cannot implement a safety instrumented function into a normal process control system because a process control system is designed with one thing in mind, and that is the complexity of the plants, right? Just like this, a safety system is designed with availability, right, and the action time in mind. There's two main factors that determine the main design of a safety system. One of them is the response time, and then the other one is probability of failure on demand. Response time would be like, okay, if you want your safety system to take a certain action, right, it acts within predetermined time frame, right? And then the probability of failure on demand is a bit more tricky, right? Say you have an unsafe condition on your plant. For example, there's a leakage in a pipeline or there is some fire on some area, right? And you want certain trip actions to be performed immediately, right? But oops, your safety system is not available, right? So what you're gonna do, it could be unavailable because of either your instrument is faulty or the wires between the instrument and the controller is cut off or your controller has gone to fault. So all these scenarios are imagined while designing a safety system. And then we have a mitigation for each of those situations. So you cannot use your process control system for safety application.
Okay, so I'm assuming there would be a number of different factors that would go into the design and implementation for these safety systems. So what criteria do you take into consideration when you want to develop a safety system?
Okay, so there is an international standard that gives you a complete guideline to how you're going to go about designing your safety system, and it includes those factors, right, that you just asked me about. So what I'm going to do is I'm not going to talk about the whole procedure and the standard, right, because it's very lengthy. But IEC 61508 tells you a whole lot of steps that you need to follow to design, to consider and design a safety system, right? One of the steps, the very first step in this process is actually hazard analysis, right? It's at some places it's also called process hazard and risk analysis, right? So what is hazard and risk analysis? It's like identify your hazards. You know there's a process, right? Be it a refinery or an offshore facility, right? So you need to know what hazards could happen in that facility, in that process that you're going to use. Now, once you have identified the hazard, you might assign a risk level to it. That how risky is that hazard? For
So
example,
these-
fire, very risky,
Yeah, so
right?
the hazards would be things like leakages, spillages, fires,
Yes, so
breakages.
all the
Yeah.
safety
Okay.
hazards, all the and each of them has their severity, right? That is the risk level associated with that hazard. So this study has a or has it, right? It's mainly focused on this process to identify the hazards, assign the risk level to it. Now, once you know your hazards, right, then there's step two, that
So
is
just
LOPA.
to wrap up a little bit, that risk level is defined by just the impact on the process, or do you take into consideration personal impact or an environmental impact, like a spill that's just losing some product versus a spill that could potentially cause an explosion? Will they have different risk factors?
Everything is imagined while doing the hazard and risk analysis, as small as putting a bucket in the pathway,
Okay.
right? And as big as taking actual operator actions on the safety system. So
Alright.
yeah, everything goes into, imagining the best possible scenarios, all the scenarios that could go wrong on a facility, right? And then once you have done your HAZOP or HAZID, right?
Yeah.
Then you go into your next step. That is again governed by IEC 61508. That is layer of protection analysis. So what is layer of protection analysis? Once you have identified your hazards, you might want to put some layers of protections around it to make sure that that hazard cannot reach the worst outcome.
So,
Right.
for example, if there's a spill, your first layer of protection would be the coating on the tubing to make sure the spill doesn't go outside into the environment.
Exactly. Yeah.
And then if it goes into the environment, it's in a safe area or in a location where
Yeah.
it
It might
cannot
not be.
be
It might not be in
ignited,
a
or
safe
it
area.
cannot, yeah, it will be in an environment where ignition or some other sources are not available to make sure that that spillage cannot create a greater environmental impact.
Yes.
It remains contained in that area.
So, and in case if there is some probability that you will have a leakage and there'll be some ignition source around, you need to shut down immediately.
So that's where your safety systems would come in. So how do you implement all of these on a safety system then?
Okay, so all of the safety functions are determined as per IEC standard, as I said earlier. And this is like I told you about the 3 steps, right? Then you boil all this information down that you have acquired from HAZOP, HAZID, LOPA, and then you know your SIL levels, right? And you write your safety requirement specification, right? This safety requirement specification acts as a backbone to or a design standard to this particular project that you are doing, right? So every project has a safety requirement specification. And then you're gonna know your safety instrumented functions very well, and you're gonna have to incorporate in your selected safety system. But of course, there's a procedure to that.
Okay, so are there any specific considerations that you need to take when you move to the design phase for safety system? What is the next step that you take once you have a need established for safety systems?
Yeah, so once a need is established, of course, you know on which facilities you're gonna need a safety system. Once that need is established, you're now going into design phase. So you take your safety requirement specification. It has all the details, right? Strictly followed. And this safety requirement specification would tell you about each and every loop. So that is number one, to follow the safety requirement specification to the mark. Then another thing that you have to consider is the compatibility of different systems that you're using in that project, because it's not just a safety system that you're using, right?
Yeah.
And then also you also have safety systems on other platforms. So all those systems have to work together. Now your process has to keep flowing, and so your regular process is flowing, and you have your product or whatever you're doing with your plant, and then the safety system have to sit back passively. So while designing the safety system, you have to make sure it works with the other safety system. One of the things that we do during the design phase and testing phase and validation phase is that we try to simulate the plant environment as it would be on plant. And then we check all the communications, make sure all the safety. In one of the projects I saw, there were some bugs in the safety system that those were ignored even during the testing. So even the testing procedures need to be comprehensive, right? So you have your testing procedures, you test each and every scenario that you could imagine that could go wrong with the safety system, and then you have your inter-trip signals. Some functionalities are additional to safety systems and sometimes necessary on some of the plants. For example, if you have your partial stroke testing and full stroke testing, you have a valve on the line that is receiving oil from an unmanned facility, right? So this valve needs to close when called upon.
Okay.
Now, if it does not close when called upon, there will be some serious damage to the receiving facility.
That is
For
true.
example, if there is a fire on the platform that is coming from, I need to quickly close the valve. This valve has been open for about an year or so. You're not sure it will close when called upon.
Yeah.
So you introduce functionalities like partial stroke testing and full stroke testing, where such applications are involved, right? And by doing so, you make sure that from time to time you stroke the valve, and you know that your valve is going to close when called upon. Now, this is one of the examples that I quoted. Then in design there's a whole lot of things that could go into design consideration because each plant is different. You just need to be aware of the general process, follow the international standard, IEC 61508 for European region, and then for American region, ISA standards also include the same language that is in IEC standard. And then once you follow the standard, you need to know your own dedicated plant very well. You know your plant, right? So you need to know the vendor product that you are picking to for the safety system as a safety system. You need to know that product, and then all the compatibility issues that could befall. So this is a normal project sequence that goes into once the need is established.
So you mentioned a scenario where an OEM provider had provided a fire and gas system and you provided a safety system. So do like the end users get to pick which systems they want, or do they ask you for a recommendation? How does this thing go?
End user is the customer, right? So a customer can go two ways. One, they can come to us and they can say, hey, this is a system that we need. We will have to give them that system. We can be restricted to a certain OEM because end user requested. And then there's another way to go about it. And sometimes end users we have good relationship with come to us and they ask us that, hey, we have this process. So we have this TCS or SCADA or whatever as a main process layer. So which safety system would you advise us to go with? And that's where we take in all the knowledge that we have. INTECH is working in 40 countries or so, and we have a good knowledge pool where we use over information that we have taken working for years in the industry to suggest the right safety system to the customer, and that'll be more reliable, and that'll be in consideration with the architecture of the customer. So these are the two ways it can go, the selection of a system.
Right. So usually when end users just dictate what system they need, is it because they're bound by some OEM infrastructure or pre-existing agreements with manufacturers, or is it maybe just they don't have the expertise in house for personnel and they'll need to train a whole batch of new personnel to work on those systems?
You got it right, actually. This is because sometimes it's the need of the architecture. There's already a system there on the plant that you want this new system to be able to communicate with.
Okay.
And that's why you're bound by the system requirement. And sometimes end users don't want to be locked in by a certain OEM,
Okay.
right? Because if a number of facilities of an end user has the same system in one territory, they would be locked in term of maintenance by that OEM. So they would like to avoid that situation. So it's those two things.
Probably increase the risk of common mode failures as well.
Increase
they
the
have the
risk of
same-
yes,
the same
increase the
system.
risk of common mode failure as well. That's the main thing.
So, considering these complex environments where you have systems from different OEMs that are maybe like you have different systems operating in different parts of different plants,
Mhm.
when it comes to commissioning or testing these systems, what kind of challenges do you come across?
There's a lot of challenges that you could face with the commissioning of safety systems. Most of them are from the point of view of integration, and some of them are from human point of view. As far as the integration is concerned, just like I said before, you need to test your architecture thoroughly, right? Then another thing that you need to make sure is your operational tests are simple. Operational test procedures are simple and easily understandable, so you can quickly test all the functions offshore as intended by the safety system. And then another challenge that you could face with was with the competency of the OEMs. There was a plant on which there was an OEM who was not able to quite test their system, so we had to jump in and we had to take lead there and try to compensate for their scope, and because things had to move on and we had to quickly do the test. So that is the human element in as far as the operational tests are concerned. Then for the system configuration, most of the things related to a safety systems are sorted before commissioning. Each and everything is carefully tested. If you have configured a safety loop wrongly, right? So you have to fix it. If you have to fix it, you have to do the download changes. If it's after the startup, it's gonna cause some problems. Then another thing is you cannot interlock, you cannot bypass your interlocks whenever you want, and that is because those interlocks are in place because of a reason. So this part is also associated with humans, and I have seen some commissionings where you can just be asked to bypass a certain interlock. Now, as far as bypassing is concerned before startup, you can always do that. There is even a provision for a time-based bypass in the startup that is called startup inhibition. Right?
So, why
It's
would
also
you bypass them during startup?
yeah. So sometimes you need a certain parameter like pressure or temperature to be within a range before you can go normal with the system. That is
Okay.
a normal system. So that's why you have startup inhibitions, and that's fine. But those startup inhibitions are recorded in the design phase. So what you need to make sure is don't go after out of the boundary of startup inhibitions and just start bypassing anything you feel like bypassing just to get some part of the equipment up, so to achieve a certain outcome in terms of plant operations. And then there's another thing that you need to be careful about, that are system inhibitions during the startup or during the after the full field shutdown, when you have a shutdown for the maintenance, right? And you want to restart your plant. Now you have immense pressure from the top management, so you have to be careful not to put safety functions on bypass just because somebody requested to do so. And a safety system engineer has full right to decline any inhibition if he thinks it's unsafe. I have seen a couple of places where some end users might ask to go beyond the domain of allowable inhibitions in the safety system.
And that's where you go stop work authority. I'm not going to do that.
Yes,
Yeah.
many good end users have that stop work authority.
That's good. I think that this has been a good session. We'll conclude it here. Thank you, everyone, for joining us for this session. We'll see you in the next session very soon. Be sure to check out our other videos on our channel. And until next time, bye.